I'll walk you through abstraction. So abstraction means ignoring irrelevant features, properties, or functions and emphasizing the relevant ones. So relevant to the given project. With an eye to future reuse in similar projects, and abstractions helps managing complexity. Abstraction is something we do every day. Looking at an object, we see those things about it that have meaning to us. We abstract the properties of the object and keep only what we need. For example, students get name but not color of eyes, allowing us to represent a complex reality in terms of simplified model. Abstraction highlights the properties of the entity that we need to hide from the others. So in TypeScript, abstraction is achieved in several ways: abstract classes, interfaces, inheritance. So only with these three things. Abstract classes are special classes that are defined with the keyword abstract. So this is the mix between class and interface, partially implemented or fully unimplemented. Not implemented methods are declared abstract and are left empty, cannot be instantiated directly. So child classes should implement all abstract methods or be declared as abstract too. So abstract methods are empty methods without implementation. The implementation is intentionally left for the descendant classes to implement it itself. When a class contains at least one abstract method, it is called abstract class, and abstract classes model abstract concept. For example, person, object, item, movable object. So here an example. I'm saying I have abstract class movable shape, which implements iShape and iMovable. And here is the keyword that I'm using. So this is the first one that you should declare. After that, I have two private fields, private y and x. Both of them are from data type number. Then I have two methods. I have method move, which is receiving two parameters, delta x, which is number, and data y for number, and returning void. Here, I'm just saying this.x and this.y equals plus equal delta x and delta y. After that, I have another method set positive. To the end, I'm defining an abstract method. So I'm saying abstract calculate surface and this return number. So I'm not implementing it, I'm just defining it, and everybody who inherits movable shape should actually implement it or again declare it as abstract. Interfaces versus abstract classes. Well, TypeScript interfaces are like abstract classes, but the construct interfaces can contain methods with implementation, cannot, and all interface methods are abstract. Members do not have scope modifiers. Their scope is assumed public always, but this is not specifically specified explicitly, and cannot define fields, constants, inner type, and constructors. So, an example of abstract classes. I'm defining and I'm saying abstract class animal, and this will implement iComparable from animal. Here I'm having private variable. I'm having private field speed, which is number, and then I'm defining two abstract methods. So I'm saying public abstract. The first one is actually method getName, which is returning string, and the second one is get for speed. So that's the get property from number. And again, I can define this as abstract, and after that, the derived classes of the parent class animal should implement it. Then I have a method compare to where I receive another animal. This returns number, and here I'm making the comparison and returning 1, -1, or 0 depending on the result. The important thing here is how I'm defining an abstract method and getter of property. Another example, I have class turtle, which extends the animal, and here I have get speed, and now I implement it. So in that case, before in animal it was abstract, but now here should be or abstract or I have to implement it. And here I'm just implementing its behavior. I have as well getName method, which is returning turtle. The same thing is I have class cheetah that extends animal, and again When I inherit them, I implement them. And here you see what's the point of the abstract. That inside Turtle class, I can have different implementation than cheater. So abstract data types, abstract data types ADT are data types defined by a set of operations, which is interface. For example, is iList, which is in .NET Framework. So inheritance hierarchies, using inheritance, we can create inheritance hierarchies. This is easily represented by UML class diagrams, and UML class diagrams, basically classes are represented by rectangles containing their methods and data. Relations between classes are shown as arrows, and close string to arrows means inheritance. Other arrows mean some kind of associations.